Hello guys, welcome back. We're going to learn how to use the mean and standard deviation of the sampling distribution to compute the probabilities using the z-score as we did before. And that is what we call the central limit theorem. In this particular case, we want to make sure that the sample size is greater than 30. Okay, once the sample size is greater than 30 and we know the population mean and standard deviation, then we can now convert to the sampling distribution mean and sampling distribution standard deviation to compute the probability. Okay, so the key word here is that the key thing to learn is that n has to be greater than 30, and of course z is used to find the normal probability. Okay, so we are going to illustrate this using this example. We have a mean college age of college students in 2009 was 30 years with a standard deviation of 7.3 years. A simple random sample of 49 students is drawn. We want to find the probability that the sample mean age is greater than 32, is less than 29, and between 26 and 35. Okay, so just like we did before, everything will remain the same using normal CDF except the standard deviation. Remember the last time when we were working with population, we used just this population standard deviation. But because we are dealing with samples, we're going to use the standard deviation of the sampling distribution, which in this case is going to be the population standard deviation divided by the square root of n. Okay, so let's look at number one. It says greater than 32. So anytime we have greater than 32, it means that the lower boundary will be that particular number. In this case is a 32, greater than 32. Okay, so the upper is going to be positive infinity, which is 1e99. That's what we're going to use to represent positive infinity in our TI-84 plus. Okay, so the mean of the population is given as 30, so it's the same for all of them. Okay, now the sampling distribution standard deviation, which we are going to use, is going to be 7.3 divided by square root of 49, which is actually 7. Square root of 49 is 7, so this is 7.3 divided by 7. Okay, so this is what we are going to plug into the calculator. So we're going to go there right now and plug that in to find the probability for the first problem. So we turn it on and go to second verse and go to number 2, which is our normal CDF. Number 2. Now the lower is 32, 32. The upper is 1e99. 1e is second comma, and then 99, and then we have 30 as our mean, and 7.3 divided by 7 is our sampling distribution standard deviation. So we go to calculate, paste, and then we'll calculate. Okay, so what we have here is 0.0276. Okay, in 4 decimal places. Okay, so that is the probability that a sample age is greater than 32. Okay, the mean sample age is greater than 32. The second one is talking about less than 29. So when we use the word less than in calculator, the lower bound is going to be negative 1e99. Okay, and then the upper is going to be the 29. Okay, so the mean is still the same, the standard deviation is the same, so we'll plug this into the calculator. Okay, so we'll go back to our calculator. We'll go to second verse, number 2, and the lower bound is negative 1e is second comma 99. The upper is 29, and then the mean and standard deviation are the same, so we're going to paste and enter. So what do we have? We have 0.1688 in 4 decimal places. Okay, so the last one says between 26 and 35. Between 26 tells us that the lower is 26 and the upper is 35. Okay, so now the sampling is going to be the same as this one, 7.3 divided by square root of 49, which is still 7.3 divided by 7. Okay, so go back to the TI-84 and go to VARs and select number 2 again, and we have 26 as our lower, and then we have 35 as our upper. The mean and standard deviation are the same, so go to paste and enter. So we have 0. That's close to 1, very close to 1, so we're going to do 0.9999. okay, that's the probability that the sample mean age is between 26 and 25. All right, so you can see that we have we did the same thing as what we did when we were finding probability under the z-score, to the left or right of z-score. Okay, but in this case the mean is the same, the standard deviation is slightly different because we are talking about sample. So we divide the population standard deviation by the square root of n. Okay, so let's proceed further. Now if we are given a binomial distribution, last time we saw that the mean of a binomial distribution is np. Okay, and we also saw that the standard deviation of a binomial distribution is npq. So if we want to approximate using z or normal distribution, we can replace the mean, population mean, with np, n times p. N is the sample size and p is the probability of success. Okay, so instead of having x minus mu, we're going to have x minus np, which is the mean of the binomial distribution, divided by the standard deviation, which is np times q. Remember, q is the same thing as 1 minus p. So for instance, is p 0.6, then q is the same thing as 0.4. That's 1 minus 0.6, 0.4. Okay, so that's how we do that when we want to use a normal probability using z with a binomial distribution. Okay, that's what we call continuity correction, which means we're going to subtract 0.5 from the boundaries or add to the boundaries, okay, for continuity. So that is what we have for today, for right now. When next we meet, we're going to be talking about confidence intervals. Okay, since then, have a nice day. Don't forget to visit look at the homework or the practice. Okay, see you. Bye bye.